Now let's move on to the next method invented by an English astronomer called Jeremiah Horrocks, who employed the transit of Venus to measure the distance between the Sun and our Earth. What he did was observing the transit of Venus while it coincidentally moved between the Sun and the Earth. And here is a caution about his observation in the picture like this. Since this method requires people to use a telescope to observe the track of Venus in the background of the Sun, so the intolerable brightness should be prevented to protect our eyes, which we may need a color filter. Maybe I may discuss it later in later topics, or project the image on a paper like this. Here is a paper, and the essence of this method is that Jeremiah Horrocks cooperated with other observers to record the transit of Venus from different locations on the Earth. For example, the A and B in the graph represent two observers who recorded the same transit event. Once they determine the relative position on the projected paper like this, they use a paper and their B dot and A dot, they are relative positions. And they could calculate the angle subtended by their observation horizons like this, the alpha. And then through simple geometry, we can deduce the equation here like this and calculate the distance from the Venus to our Sun. So here the geometry is all related to, like, with the triangle we use some like the dashed line to make some right angles and just use a tangent to solve the question. And the last step is to apply the Kepler's third law to the equation. And this law was published 2 years before the use of transit of Venus. It did provide concrete data that assisted Jeremiah to deduce the distance between the Sun and our Earth to be 95 million kilometers, which is 2/3 of today's measure value. Okay, now let's talk something about the Kepler's third law. You have seen that the mean distance to the Sun from Earth is set to the unit value of 1, and from the Sun to the Venus is 0.724. And from the equation above, we have both these two values in the equation, so we can just re-input the relationship between them and calculate the final distance. So if you are really interested to this calculation process, you can try it by yourself because it's not a big deal to do those derivations. And the current distance between the Sun and our Earth can be 1 AU, which is called 1 astronomical units, like here, and nearly equals to 150 million kilometers. And in astronomy, we just call it 1 AU.